Welcome to my YouTube channel. It's me, Apodu Gaurav, and today is my topic in mathematics, which is application of Anova. Let's begin. Welcome to this overview of Anova, a powerful statistical tool for analyzing data and drawing meaningful conclusions. What is ANOVA? Analysis of variance. ANOVA is a statistical method used to compare means of two or more groups. It assesses whether there are significant differences between the groups or if the observed variation are due to chance. Comparing groups. It helps determine if there is a statistically significant difference between the average value of groups or if the difference are likely due to random variation. One way ANOVA. One factor used when you want to compare the mean of two or more groups based on one independent variable. It determines whether the means of the group are statistically different from each other. Second, example analyzing the effectiveness of three different types of fertilizers on plant growth. Assumptions of one-way ANOVA. Normality. Data within each group should follow a normal distribution. Homogeneity of variances. The variances of the group should be roughly equal. Independence of observation. Each within each group should be independent of each other. Two-way ANOVA. Two factor. If want to examine the effect of two independent and the variable of the independent variable. Second, interaction effects. It can analyze the interaction effects between the two factors, meaning how the combination of level of the factor influences the outcome. Assumption of two-way ANOVA. The data within each group should follow a normal distribution. The observation within each group should be independent of each other. First, second, third, and fourth. And the second, the variance of groups should be roughly equal. And the fourth is the variance of the differences between measurements within each group should be equal. This assumption is important for repeated measures ANOVA. Repeated measures ANOVA within subject design. Used when you have repeated measurement from the same subject under different condition at different time points. Example, studying the impact of a new treatment of patient symptoms over a series of weeks. Assumptions of repeated measures ANOVA. First, normality. Data within each group should follow a normal distribution. Second, sphericity. The variances of the difference between measurement within each group should be equal. Third, independence. Observation within each group should be independent of each other. When to use ANOVA? Comparing means. When you have two or more groups and want to compare their means to see if there are statistically significant differences. Multiple independent variable. When you have more than one independent variable and want to examine their individual and interactive effect on individual variable. And the third one is repeated measures. When you have repeated measurements from the same subjects under different conditions or at different time points. Interpreting ANOVA results, p-value, and F statistics. P-value, significance. The p-value tells you the probability of observing the results if there is no real difference between the groups. Effect size. The F statistics measures the ratio between group variability to within group variability. A large F and of a statistic indicates a stronger effect of the independent variable. So, what we have concluded in our topic, interpreting now ANOVA results, application of ANOVA, what is ANOVA, analysis of variance, comparing groups, one way ANOVA, one factor and the example, assumptions of one way ANOVA, which is normality, homogeneity of variances, independence of observations, two way ANOVA, two factors and the interaction effects, assumptions of two way ANOVA, which has included four steps. Repeated measures ANOVA within subjects design and the example. Assumptions of repeated measures ANOVA, which included first one is normality, second one is sphericity, and the third one is independence. And when to use ANOVA, which included one comparing means, second multiple independent variables, and third one is repeated measures. And the last is interpreting ANOVA results, which included the p-value and F statistics, and in which p-value includes significance and the F statistics includes the effect size. Thank you.